So guys, welcome back to the new video. Today we are going to talk about two-dimensional array. So guys, in our previous videos we have discussed about a single dimensional array. So guys, in single dimensional array there was only a single dimension where we used to store homogeneous elements, but in two-dimensional array here it is a combination of both rows and columns. So whenever we want to store a data in the form of a table, in the form of rows and columns, then we used to go for two-dimensional array. So guys, let us see the syntax of two-dimensional array. So it is as same as one-dimensional array, but there is some minor changes. So first we have to declare the data type, whether we want integer type of array or floating type of array. So then the array name, whatever name you are going to give, the condition is the name must be start with English alphabet and or underscore. So that name that you are going to give it a array name. Then here in single dimensional array, what we used to do is we just give a size, right, the maximum size, which we might use or might not be used. If you don't use it, then it will get wasted. So in two-dimensional array, what we do is here we give two sizes. The first one, let us take it as x, and second one which is take it as y. So here x is the size of first dimensional, which is known as rows, and y is the size of second dimension, which is known as column. So here x refers to the rows and y refers to the column. So whenever we are going to access the elements, we have to access in the form of rows and columns. So guys, the index will be 0, as same as one dimensional array. Its index will also be 0, and y's index will also be starts from 0 and ends with maximum size -1. So guys, here let's say I have given the size 3. So here I can store 3 into 3, that means 9 elements. So guys, here the first index would be x of 0 0. So it is the first index. This 0 refers to the row and this 0 refers to the column. So guys, this is the first index where I used to store the value, and this is the second index of 0th row and 1st column. So guys, this is the third index, and here I can store the third value, which is 0th index, which is rowth index, and it is column index, which is 2. So guys, similarly, if I give size like 3 and 3, so the 3 rows and 3 columns means it will multiply it, and 3 and 3 product of 3 and 3 will become 9. So I can store 9 elements here. So guys, let us see it through this program. And guys, let's see this. Here I have declared an array of row size 4 and column size also 4. So here I can store 16 values here, 16 homogeneous elements here. So which is our data type of integer. So guys, I have taken the row size for giving the size by the user, and this is the column size for reading the size from the user, and I am doing the sum of diagonal elements here. What is diagonal elements? So guys, let us talk about diagonal elements. So guys, here the diagonal elements are 0 0, 1 1 and 2 2. So these three are going to be diagonal elements. Guys, this is a diagonal element, this is the second diagonal element, this is the third diagonal element. So whatever the value we are going to store in the first diagonal element, second diagonal element and third diagonal element will going to be add, and so it will show us the sum of both diagonal elements. So guys, let us run this program and let us see the output and understand what's going on. So guys, let us give me the row size 2 and column size 2. So here I can enter 4 elements here. The product of 2 into 2 will become 4. So that's why I have entering 4 elements, 4 3 2 1. So guys, here you can see the 0 0, that means the first index, the row 0, the column 0. So the first row and first column value is 4, and the row first and the column second value is third. So the 1th row and 0th column is the value 2. So the 1th row and 1th column is containing the value 1. So guys, here the sum of diagonal elements, as I have told you, diagonal elements are 0 0, which is having 4, and 1 1 index, which is having 1. So guys, 4 plus 1 will be 5. So this is the sum of diagonal elements, which is showing us 5. So guys, let us see another output by giving it size 3 and 3. So guys, here the first 3 will go to the row size, and second 3 will be considered as the column size. And guys, the product of 3 into 3 will become 9. So I can here I can enter 9 elements here, and 9 elements will be like -6, 8, 9, whatever values, integer values you are gonna put here will going to be show in the output screen, and it will make the sum of diagonal elements, and it will show us. So guys, -6 plus 4 will become -2, and -2 plus 6 will become 4 plus 4. So guys, sum of diagonal element is +4. The diagonal elements are -6, 4 and 6. So guys, if you add these 3 elements, then you will get the sum 4. So guys, here the index, you have to see the index and understand that this is the first ever element. First row and first element is -6, first row second element is 8, first row third element is 9, and second row first element is 5. Here the second row second element is 4, and second row third element is 3, and similarly here third row first element is 2, and third row second element is -8, and third row third element is 6. So guys, this is what the two-dimensional array are called. So whenever you know that you have to store data in the tabular form, in the form of rows and columns, then we used to go for two-dimensional array. Otherwise, if there is no need of two-dimensional array, you can also go with single-dimensional array. Yeah, for doing this sum, I have to give a square matrix only. Square matrix means where the row size and column size must be equal. So if the row size and column size are equal, then it is said to be a square matrix. So guys, here I have given the condition: if row size is not equal to column size, then it will show us the place into a square matrix. This is not a square matrix. Rows and column size must be same for doing operations. So guys, if the rows and column size are same, then these operations will be executed, which is nothing but I'm just calling the read 2D array function and print 2D array function, and I am printing the sum of diagonal elements in the main function itself. So guys, here I have declared two functions. One is for reading two-dimensional array, and here is for printing the two-dimensional array. So guys, here if I give the row size and column size unequal, let us say if I give the row size 2 and column size 3, so this will not be wrong, but in the case of doing operations, you need a square matrix. So doing like sum of elements or multiplication of elements, difference of elements, you need a square matrix to do such operations. So that's why I have given the condition here. If you remove that condition, then there is no problem in that, then you can't able to do such operations. So guys, this depends on your requirement, right? What do you want? So guys, here I have removed all the conditions here, and now I can give the unequal size also. So here I am giving the row size as 2 and column size as 3. So I can enter 6 elements here. So let us enter the 6 elements, and guys, 6 elements are printing here. Because I have given the row size 2, so there are only 2 rows. See, this is one row and this is the second row, and I have given the column size as 3. So guys, column are 3 here. So this is the first column, and this is the second column, and this is the third column. So guys, here sum is 5 and 1. So diagonal elements are only 2. That's why I have said that you must have a square matrix for doing such operations like doing sum or doing difference or doing finding out the product. So guys, this is what two-dimensional array is. So if you have any query or question related to this video, please comment down below and let me know. Thank you. Bye. Have a nice day.